So when you've got questions that relate to pressure being increased or volume being increased, or pressure being decreased or volume being decreased, what we're looking at here is the sheer number of gas molecules on each side of the reaction that we're given. Occasionally you will be given reactions where there are solids. Solids are not affected by pressure or volume here. Same with liquids, pure liquids for that matter. So all you're really looking at here are the gas molecules. Now there's three possibilities that can occur when we change the pressure or the volume. Either the reaction can shift to the products or to the reactants, or there could be no shift. In this instance, what we do is we count up the number of gas molecules on each side. We see there's 7 gas molecules here. We see there's 7 gas molecules here, 4 and 3, 5 and 2. So in this case, the reaction won't shift. But let's pretend that we had 4 molecules total on this side and 3 molecules total on this side, and we want to see what would happen if the pressure was increased. Well, if we look at these two diagrams here, they're diagrams of a piston, you can see what happens to the pressure and the volume in those situations. If pressure is being increased, that means we're pushing down on a piston. Of course, the pressure increases and the volume decreases, so the volume goes down. That means there's less volume for molecules to be in, so it's going to be more favorable to be on this side, which means it would go towards the product side if that were the case. If we had this situation where we had, we'll say 4 and 3, and we're looking for volume decreasing, so volume decreasing, that's this situation again, and again it would move to this side, to the side with fewer gas molecules. If volume was increasing, then it would move to the side with more gas molecules, which means it would move to the product side. The other question here has to do with the heat. So it says here, in which direction will the reaction shift if the reaction's cooled? So that could be cooled or heated. And what we've got to do here is look at where heat is in the reaction. So if heat is here on the product side, it means that the reaction is producing heat and it's kind of like a product. So I would just treat it like I would a product or a reactant. In this case, I treat it as a product because it's on the product side. If the reaction is being cooled, what that means is that heat is being removed. So if a product is being removed, that means the reaction will shift to this side to compensate for that. If heat happened to be on the reactant side, what that would mean is the reaction would shift to this side, to the reactant side.